Hey everyone, this is Mohammed Nadeem and welcome to my YouTube channel. Today in this video, we will discuss that what does mean by internal resistance of supply and what does its impact in the circuit. So let's consider this circuit. We will see this in the simulation. So for a quick recap, we are using let's say we have this circuit. So this circuit consists of the battery here. This is the negative terminal of the battery. This is the positive terminal of the battery, and this is connected to the bulb here. So when this circuit is closed, then the current I will flow through this wire toward this resistor. So this current is produced. So here the force and the the force and the electrons present inside the wire is come from the reaction which is occur inside this battery. So when here inside this battery we have, let's say this is the battery and these are the plates which is present inside the battery, and let's say we have this battery. Inside this battery we have some electrolytes. So in this case, inside the electrolytes, we will have some ions. So that ion, the positive charge molecules in the electrolytes will come towards, let's say, the cathode. So here this is the cathode, and the negative charge molecule will come towards the anode. So here in this way, the ions in the electrode will move towards these cathodes and anodes, and due to which the charges will be transferred between that electrolyte and these anodes. So in this case, some collision will be occur, and due to and in this case some accumulation of the charges occur. So due to that accumulation and the internal phenomenon occur inside this battery, due to the internal phenomenon occur inside this battery, some resistance will produce inside the battery. So the one thing from the battery is that it give us the electromotive force. But instead of it's giving the electromotive force, some of the voltage is dropped inside this battery by itself. So that release of the internal voltage inside the battery due to the resistance occur between the electrolytes and these electrodes. That resistance occur inside the battery is called the internal resistance of the battery. So the battery with more internal resistance will give us the less voltage to the circuit. So here every a real battery will contain some internal resistance, because during the redox reaction inside the battery, some collision and some phenomenon occur. So due to that phenomenon and due to that condition inside the batteries, voltage and some of the energy will be dissipate inside the battery. So the dissipation of energy inside that battery is called the internal resistance of the battery. So this internal resistance is actually the resistance which is present inside the battery by itself. So the second one is, and here this is the internal resistance, and here its impact. The impact in the circuit is that if the internal resistance here the internal resistance, I'm going to represent the internal resistance as small r. If the internal resistance of the battery, okay, this is small r, if the internal resistance of the battery is high, then what will happen? More energy inside the battery will be dissipated before giving it to the circuit. So if the internal resistance is high, then here the voltage provided to this source will be less. So in this case, the voltage provided to in this case the voltage provided here is will be less. So, and similarly, in the second case, if the internal resistance of the battery is lower, so the battery having lower internal resistance mean that it is the having good better quality. So if the battery is good, then their internal resistance will be less. So due to some engineering, electrical and mechanical engineering, we design the battery in such a way that their internal resistance is to be less. So if the internal resistance of the battery is less, then it will give more voltage to the circuit. So this is the impact of the internal resistance. If the internal resistance is more, then the voltage provide to the circuit will be less, and if the internal resistance of the battery is less, then more voltage will provide it to the circuit. So that is the internal resistance of the battery here. This is the battery, and now this every battery, which is every real battery will consist some internal resistance that may be greater or less, but there must be some internal resistance. So only the ideal battery, which is actually the hypothetical battery do not consist of internal resistance, but that will not present in the real world. So every battery present in the real world will have some internal resistance, and some of the engineers are trying to reduce the internal resistance of the battery. So that internal resistance have some effect in the circuit. So here I have written that every real source of electromotive force. So the here in this case the battery is the source of electromotive force, as I discussed in the previous video. So every real source of electromotive force has internal resistance, which affect the voltage available to the external circuit. So here in this case, the internal resistance is more, then less voltage is available for the circuit. So here it mean which the internal resistance affect the voltage available to external circuit. As the current flow through the source, a voltage drop occur across the internal resistance and reduce the output voltage. So how the output voltage is reduced? So for that I am going to draw the circuit here, a simple circuit here. We have this uh, we have this battery. So here we have this battery, and inside the battery we have the I'm going to label it here. Inside the battery we have, so this is we have the source. This is actually the electromotive force. So here this is the electromotive force, and inside the battery we will have some resistance. So this resistance in our case is represented by R. So this is actually we have the battery. So inside the battery we have the electromotive force. That electromotive force is come in the battery due to redox reaction. And when the redox reaction occur, due to that during that phenomena, some resistance will be occur. So that resistance is called internal resistance. So this is actually a battery which have the electromotive force, and inside the battery we have the internal resistance. And similarly, I am going to connect this terminal of the battery. So let's say now this is the positive terminal of the battery, let's say, and this is the negative terminal of the battery. We connect this with some resistance here, resistor. Let's say I am going to mention the resistor explicitly as the bulb. So here we have the bulb, and this is connected again to the negative terminal of the battery. So here this is the circuit. This is actually the circuit diagram, and inside this the circuit diagram we have the electromotive force as represented by this, and we have the internal resistance, and here the current I will flow in this circuit, and here this resistor have some resistance R. So from here we can apply um, the Ohm's law. So here Ohm law, V is equal to IR. But in this case, resistance is actually the combination of this capital R, which is upper by this resistor, and similarly this small r, which is upper by the battery. So here I am going to mention explicitly that I is come in its own position. Instead of this r, I will write r plus r. Here in this circuit, now we have two R. One is this internal resistance and the other one is this resistance. So from here I'm going to find the current. So I is equal to uh, here I is equal to V. Here I is equal to uh, in this case I is equal to uh, V by R, small r plus capital R. So this is a small r plus capital R. So in this case, we have, this is actually the electromotive force. This is the electromotive force in this case. This electromotive force is equal to IR. So here I represent this R with this capital R and this small r, and it give us this. So here we have, this is the electromotive force. Now this is the electromotive force. This is the simple formula. So here what I am going to do is that rearrange this equation. So in order to rearrange this, it will give us this. So here we have the electromotive force is given by I uh, capital R plus I small r. So in here, this is I passed through this R is equal to V. So V is equal to IR. So here I am going to write that instead of this capital R and I write V here. V is equal to IR plus I and this small r. So this is the equation for the electromotive force. So in this case, electromotive force for this circuit is given by the potential difference plus the potential here through this here through this resistor, in this case the bulb, plus the internal resistance and the current pass through that internal resistance. So I and this small r. So this is the equation. This is the equation for the electromotive force here. So electromotive force is equal to the voltage here inside the battery, and similarly voltage here outside the battery. So if I put the R, the internal resistance is 0. So for the in the other word, for the ideal battery, what we will do is that for the ideal battery, the internal resistance is 0. So here is the space. So for that, I am going to. So here we have two conditions. First is the I'm taking this R. So for the real, this small r always be present. So for the real battery, this small r will always present. Here internally, the resistance will always be upper. So for the ideal battery, we will put R is equal to 0. So this equation, let's say this is equation 1. So let's say this is equation A. So in the first condition, equation A will apply that if we put this R is equal to 0, internal resistance is equal to 0, then this equation become epsilon is equal, sorry, the electromotive force is equal to V plus I, and instead of R we will put the 0, so due to which this term become 0. So here it uh, show us that if for the ideal battery, the electromotive force will be equal to the voltage, the potential difference across the terminal. So here we have the potential difference. So for the ideal battery, there will be no this resistance. So in that case, this electromotive force of the battery will be equal to this voltage here. So this is the equation for that. And what how to find the voltage here in this resistor? So here the voltage in this case will be equal to this electromotive force minus IR. So this is the voltage through this resistor for the open circuit. So for the open circuit, R will be 0. This small r will be 0. So if we put the small r here 0, then the internal resistance, then the electromotive force will be equal to the potential potential difference here. So this is for the open circuit. Now for the closed circuit, there must be the internal resistance. So this internal resistance will not equal to 0. So if the circuit is open, there must be some redox reaction due to which heat will be produced and due to which some resistance will occur upper inside this battery. So for the closed circuit, this R will not equal to 0. So in that case, the voltage is given by this formula. So here the voltage will be given by this formula, and the voltage is given by this formula, and the uh, electromotive force will given by this formula. So here the V in this case, V voltage is equal to voltage across this resistor is equal to electromotive force minus current times of the internal resistance. So here in this case, this voltage, the voltage passed through here will be reduced from this electromotive force. In this case, this electromotive force will be more. So this voltage is decreased by this factor. This voltage will be decreased by this factor. So in this case, this voltage, in this case, what I'm going to mention here is that in this case, the voltage will be lesser and electromotive force will be more. Here we have this 9-volt battery, and this is connected with this bulb. The bulb have 10-volt resistance, and we can change that by click here, and from here I can change that. So, and this is the voltage and we also change that by clicking on this. So our desire is that we are so let's uh, here put click on this advance and here we have the battery resistance. So this is the battery internal resistance. If I increase this so now if I put that internal resistance here, this is the 2 ohm. 2 ohm is the internal resistance of the battery. Due to that 2 ohm internal resistance, the current flow in the circuit has reduced. So I'm going to further increase the internal resistance of the battery, then the current will be reduced. So here the I'm going to increase this and here the current will be reduced, and if I reduce this internal resistance, then this current will be more. So and for the ideal battery, this internal resistance will be zero, and this the current will flow, the more current will flow through the circuit. So this all about the internal resistance and their impact on the circuit. If we increase the internal resistance, the current flow through the circuit will be reduced and more opposition will provide through the full flow of electrons. And if we reduce that, this then this current will be increase. And similarly, if I reduce it to zero, so if the internal resistance is zero, then the current flow will be higher. So in the last step, what I'm going to do is that here I'm going to cut this. Now this circuit is closed. This circuit is open. In this case, I am taking this voltmeter. So for that, I am taking this voltmeter, and similarly, I take the internal resistance. So here, this is the battery will have internal resistance 5 ohm, and its own voltage is 9 volt. So in this case, the output of this battery is actually we have this, the output voltage of this battery is 9 volt, the same voltage as its inside its inside this battery. The same voltage will present at the terminal of the battery. This electromotive force is equal to V minus IR. So if this is open, so in this case for the open circuit, we will put R is equal to 0, because the current here in the open circuit, for the open circuit, this current will be 0. So if this current 0, then 0 multiplied with R, this portion will be 0, and in this case, electromotive force will be equal to the voltage here. The voltage here, this will be equal to the voltage here. So in this way, the internal the electromotive force, the voltage of here, the internal electromotive force in this case is 9 volt, and the potential difference I measure through this voltmeter is 9 volt. So in this case, this V and this electromotive force is same, and it satisfied this condition.